Today we are going to start with a topic that is the IUPAC, right? So first of all, you should know that from where, what is actually this IUPAC and from where it came, right? So you know that many elements are already discovered and still the discoveries, many discoveries are in pipeline, right? So we need a certain, you can say, organization which should specify a name to an element that can be accepted worldwide, right? For example, what was happening actually before this IUPAC was you can say launched, what was there, like some element was you can say was discovered by the Germans, right? So they named accordingly, and if some element got discovered in the America, it was named accordingly, right? But actually we need a name which should be worldwide accepted, right? And that came from the organization that is IUPAC. You know, IUPAC is actually an international union of pure and applied chemistry, right? It is a Geneva system. It is a, you can say, a system of naming elements which was or you can say given by the System International, right? So this IUPAC was launched in 1947 and was revised in 1993. Like, I think you are familiar with this abbreviation now. It is International Union of Pure and Applied Chemistry, right? So let us see that how it named the element accordingly. So according to the IUPAC, the name actually consists of three parts, or you can say it is divided into the three parts. So just look at the board, what are those three parts? It is the prefix, it is the word root, the second part, and the third part is suffix. Now you must be anxious to know that what do we mean by this term prefix, word root or suffix, right? So just let me tell you in detail what actually they denote. The prefix is indicated by the, you can say, the substituents which are present in any organic compounds. Right, don't be panic, you will get to know that what are substituents actually. So for this moment, just you can say you have to grab this, that prefix indicates the substituents, right? We'll be discussing later in detail. So three parts are prefix, middle one is word root, and the third is suffix. Prefix indicates the substituents which are present in the organic compound. Now which groups are considered to be substituents we'll be taking later, right? Second, word root, it actually specifies the number of carbon atom in chain. That means the number of carbon atom present in an organic compound, right? So it is specified by the word root, right? So the third part, which is called as suffix, you know what is suffix? Actually it is a ending, right? It is commonly used in a daily routine as well. The suffix means ending, right? So similarly in this case, the end of the name is called as the suffix. This suffix is actually divided into two categories. One is primary suffix and the other is secondary suffix, right? So what is the, you can say, what is the reason behind to divide the suffix into two parts? The reason is so simple that actually the primary suffix indicates the type of bonding present in the organic compound. It indicates the type of bonding. As you are familiar that we have alkanes, we have alkenes, we have alkynes, right? So we know that in alkanes there is a single carbon bond, and alkene there is a double bond present, and in alkyne there is a triple bond present. The number can be 1 or 2, it varies according to the organic compound. But still, so what is the main concern we are here? We are just, the concern is that the primary suffix just indicates the type of bonding, that whether it is single bond or double or triple, it is the, you can say, the suffix is used accordingly. Next is the secondary suffix, right? Secondary suffix actually indicates the functional group if present in a compound, right? So it just indicates the functional group, and I think you are familiar that what is functional group? Functional group is actually a group of atoms which actually determines the properties of the compound if they are present, right? So similarly, I think you are familiar with the meanings of these three words. Again, I am repeating for you. The name is divided into three parts. The first part is prefix, the middle one is word root, third is the suffix. In the same way, we are going to write the name. Like if we are going to name some kind of organic compound, we look for the prefix first. We'll write at the first letter, but they will, or you can say they will form this first part, right? Then we'll count the carbon atoms, and it will form the word root. And the third part, the ending part, will consist of, that is the suffix indicating the type of bond, and if functional group is present, then also one more suffix is attached to the primary suffix, that is the secondary suffix, right? So this is how we are going to name an organic compound, right? So just let us study these substituents, number of carbon atoms, these primary suffix and secondary suffix in detail. So first part, the main part, what we want when we are writing in IUPAC, we need a word root, right? So as I told you, word root indicates the number of carbon atom in a chain, right? So what word we are going to use by counting the carbon atoms, right? So if there is one carbon atom in a chain, you are going to indicate by using a word root meth. And if it is 2, then eth, 3, prop, 4, but, 5, pent, 6, hex, 7, hept, 8, oct, 9 is non, 10 is dec. I'll write the number as well accordingly so that you may not get confused in any case. And these are so simple to remember because the few words you are using already in mathematics as well, right? Like you know that 6 is hex, right? So similarly you have different these word roots, so I don't think so that it is difficult to learn. Moreover, we have the word root more than 10 also, that is 11 is undec, 12 is dodec, 13 is icosane, it is ICOSANE, right? I think it's clear. 14 is triacotane, like that. There is no O. So yeah, there is O. TRIACOTANE, right? So we have few more, but I think according to your standard, you need to remember only till 11, 12 because you may not get a question which will be beyond 12 carbon atoms, right? So just write in your copies that 1 indicates the meth, 2 carbon atom. If there are 2 carbon atoms present in a chain, then we use the word root eth, and if there are 3, then prop, 4, then but, 5, pent, 6, hex. Pent and hex you already know, right? 7 is hept, again you know that, you use in mathematics heptagon and like that, right? 8, oct, 9, non, 10 is dec, right? And 11 is undec, dodec, icosane and triacotane. So this is how first you can say they form actually the tools of the ecosystem, the IUPAC, right? So you need to be well versed with the word root, because if you are not well versed with the word root, you may get confused while writing a name. So the first or you can say the first tool which you have to be well versed is the word root. That is, you should be familiar that what word you have to use while writing the IUPAC, when you count the carbon atoms in a chain, then what word you are going to specify which will indicate the number of carbon atom, right? So this is a very important, right? So first of all, I think you have written in your copies these word root. So you are familiar with this thing, word root, we have already done. It is so simple, it is just the counting of carbon atom in a chain, and accordingly then we'll see the number of carbon atom and accordingly we'll use that word, right? If I'll give you a compound, and suppose I'm giving an example, I give you this compound and I just ask you that what will be the word root for this compound. So it is so simple, you just have to count the carbon atoms. See how many carbon atoms? 1, 2, 3, 4 and 5. Straight away it will cling to your mind. 5 means pent, so obviously you are going to use the word root as pent. So this is how you are going to indicate the word root. You will just have to count the carbon atoms in a parent chain and you just have to write it. One more thing which is very important, we'll be discussing later, but still I'll give you a hint at this moment. It is not a compulsion that you have to count all the carbon atoms which are present in an organic compound, then you are going to name it, right? They are the carbon atoms which specifies the word root. They are only those carbon atoms which are included in a parent chain. Just make a note in your copy. These are the carbon atoms which are present in a parent chain. I'm not talking about the substituent carbons. We are not talking about or any other carbon which is out of the parent chain. It is just concerned with the carbon atoms in a parent chain. Right. So you are clear with this word root now? I think it's very easy just to count the carbon atom in a parent chain and accordingly use the word for it. Right. So this is the word root. Now, what happens? What is this suffix now? We'll be studying the suffix, that is the ending. As I told you that suffix is divided into 2 categories. Right. So first is the primary suffix which is written prior and which is followed by a secondary suffix. Primary suffix actually indicate a type of bond, right? Like, I'll give you an example we'll be doing the rules as well, but for this moment, to make you more understand this concept, I'll give an example. So see, look at the board. Suppose I give you a compound, right, and you just see the only compound which I gave you is this, right, and I ask you that what will be the primary suffix for it. So what you will see, you must be knowing that primary suffix indicates the type of bond. So what kind of bond do you get to see in this? Tell me, what kind of bond? Yes, it is a single bond. See, CC is a single bond. Here is also a single bond between C and C, and here you get to see again a single bond. So that means the primary suffix will be only for it will indicate a single bond only, right? And we know that for a single bond, what suffix we use? Single bond falls in the category of alkane, right? And the suffix we use for alkane, you already know, is ane. So that is what we are going to use for it. So if I ask you that what is the primary suffix, for example, I gave you, you're just in a second you are going to say that yes, because we are able to see only single bond present, so that means the suffix is ane, right? And if there is a minimum one double bond present in a chain, suppose it is like that, so to what category it belongs? Obviously it belongs to an unsaturated category. We know that if there is single bond all over the molecule, that means it is a member of alkane. But if there is minimum one bond present is double bond, then it do not come under the category of the saturated one, it becomes unsaturated one, right? So for unsaturated, you will get to see if there is a double bond, that means it is a member of alkene, and if there is triple bond, it is a member of alkyne. So what you get to see in this example? Obviously, you get to see all single bonds but with one double bond. So one double bond means it is now not a member of saturated compound, it is a member of unsaturated compounds. And which unsaturated? Obviously alkene, because you get to see double bond, right? So we'll be using the suffix accordingly, and we know the suffix for the alkene is ene. So this is what we are going to answer it. And similarly, if I just make a bond like triple and I ask you that what is the primary suffix for this example which I stated in front of you. So again, you will be looking for the bond. You will see single bond, but a triple bond. Triple bond means yes, unsaturated compound. And which unsaturated? Obviously alkyne. And for alkyne we use suffix, that is ine. So this is how, I think it's very simple. It is just to look at the bonds and accordingly just use the primary suffix as ene, ane or ine, right? So this is how you are going to indicate the primary suffix. Make one note in your copy. Like for example, if I say there is a bond like this, right? If I state an example, C triple bond C, single bond C, triple bond C, right? I ask you primary suffix for it, then what you are going to say? Obviously you are going to say that yes, it contains one single bond and it contains two triple bond. So obviously it is not a member of saturated compound, it is a member of unsaturated. And which subgroups of unsaturated? Obviously alkyne, because you know triple bond corresponds to alkynes. So you will say that yes ma'am, it is a member of alkyne, right? So but what suffix we will be using in this case? Obviously it is going to be ine, right? But there is a difference, like I stated an example before. If I indicate this compound and I ask you the suffix, you will say yes ma'am, it is going to be ine. Definitely it is ine for it. But for this it is not ine. Why it is so? Do you have any idea? Yes, it is not ine because we get to see triple bond, it's okay, but we get to see two triple bond, and for two triple bond means something else. See, if I have one marker, it means something else. If I have two marker, then it needs to be specified that I have two marker, right? So how you say? Like if I have one marker, so I say I have got a marker, right? If I have two markers, then how I just say it? I say I have got two markers. You put S along with it, which indicates that you have more than one. Similarly, we do in this case, we get to see two triple bonds. So we need to specify that there are two triple bond present. So how we'll be doing that? We'll be prefixing di, tri, tert, you can say in front of the prefix. Like obviously the primary suffix is going to be ine. It is okay, and you know that it is an ine. It falls under the category of unsaturated compound. But how many ines? Two ines. So you'll write it is diine, right? And similarly, if you get three, you are going to write triine, And if it is 4, you are going to write tertine. So this is how, that means if there is a, what I mean after explaining this, I want to tell you that if there is a triple bond, you need to specify, yes, the primary suffix is "-ine", right? But if there are more than one triple bond present, you need to specify that yes, there is more than one triple bond. So how you will be doing that? By using the prefix di, tri, tert likewise, right? So this is very important. If you won't be writing di, tri, your whole question is going to be wrong. So you need to specify that yes, di, tri, tert, whatever, that means the 2 double bond are present or 2 triple bond are present. It same happens with the double bond as well. So this is what is indicated by the primary suffix. I hope you have written this di, tri, tert in your copies as a important note. Yes, it is very important, so do not forget it. So I think you are clear with the suffix. Again, I am repeating, suffix means the ending, primary suffix and the secondary suffix. Primary suffix indicates the type of bond. We have 3 options for that: single bond "-ane", double bond "-ene", triple bond "-ine", right? And if you get to see this thing more than one kind of bond, we specify that it is di, it is tri, it is tert, but it happens only in case of alkenes and alkynes, not in case of alkanes, right? Like for example, if I'll write this and I ask you for this thing, that what is the primary suffix? So you will be writing "-ane". You won't be writing it is tertane, right? Because we don't have to specify, because minimum bond present between the atom is a single bond. But after that, if something else is present like double or triple, then you have to specify that it is di, tri or something like that. For case of alkanes, you don't need to mention that it is di, tri, or do not indicate the number of single bond, right? So that is only with what primary suffix we are going to use. We are going to use only "-ane". So this is how we do for primary suffix, and I think it is clear. Similarly, what does secondary suffix indicate? Now the question comes, where we have to use this secondary suffix and under which situation we don't have to use it, right? So like I gave you this example. So what you get to see here, there are all C and there are all double and different kinds of bond, you can say. So in this case or in this case, in both the cases, I must say there is no functional group, because you know that functional groups are indicated by a particular kind of atom or a group of atom, and in these molecules we don't get to see any other atom other than carbon and hydrogen. So that means there is no secondary suffix present. So it is not compulsory that in an organic compound that secondary suffix is going to be present, right? So if in case you have the secondary suffix, or if you have any functional group, then attach the secondary suffix with the primary suffix, and if you don't have any functional group, just end the name with primary suffix, right? So because I want to understand the secondary suffix, so we are just considering few functional groups and the suffix used for those functional groups accordingly. I've just listed them here. These are not all actually, these are few, right? So the functional groups which can be attached to a chain is alcohol. How we say that it is alcohol? When there is an OH group, that is hydroxyl group. So what suffix you will be using? You will be using all. I want you to write down as I am explaining you turn by turn, so just make a note in your copy, right? So if there is OH group attached to a chain, like I say that there is a C and I get to see this OH. So by looking at this OH, it should strike in your mind that yes, there is a functional group. And which functional group? Hydroxyl group indicates the alcoholic group. That means the functional group is alcohol. And what suffix we are going to use? The suffix we are going to use is all, right? And similarly, second functional group is aldehyde. It is not in the order that you have to learn that second is aldehyde, because I have summed up in this order, then that is why I am telling that 1 this, 2 this. You can learn in any case, but the only thing that you should be familiar with all functional groups along with their suffix as well. So second means aldehyde. So when you get to know that there is an aldehyde present in a chain, if you see a compound like this, so this means it is an aldehydic group. So that means you will say that functional group present is a aldehyde. So which suffix you are going to use? Obviously it is used as al. Aldehyde means aldehyde suffix is al. Ketone, it is C double bond O and the suffix is an. Similarly, ester, C double bond COO, in which there is one double bond with O and one single bond with O, right, like this, right. So it is said to be O8. The suffix used is O8. Acid amide, CONH2, acid amide NH2. right? So it is CONH2 and the suffix used is amide. I hope you are writing along with as I am explaining you. The next is acid chloride, COCl, and the suffix used is oil chloride. Next is amine. Amine means NH2, right? And the suffix is used as same as the functional group, that is the amine. Nitrile, it is CN and the suffix used is nitrile. So there are so many functional groups which we come across, and these are only few. Don't think like that these are the only functional groups present. There are so many functional groups. I have listed few for you. So just go through all the functional groups. I am just telling you the method how we do it, right? So you just need to know the functional group, and you need to know that what are the atom or the group of atom that specify these functional groups and the suffix which are used accordingly, right? So this is how we are going to indicate this secondary suffix. Now there is a specific rule as well which we will be using.